A microgrid is composed of loads and distributed energy resources operated in concert with one another and operates in either grid-connected mode or as an island disconnected from the grid. Meters on the left are associated with distributed energy resources in this microgrid. The red meter at the top shows the output of the critical building backup generators. The yellow meter in the middle shows the output of the peaker plant connected to the main substation. This generator is sized for black starting a critical feeder and used for peak load shaving during grid-connected operations. The blue meter at the bottom shows the output of a solar photovoltaic array. This is the main electric utility line feeding the base, including the main electric service disconnect. There's a power outage and the entire base goes dark. For safety reasons, the PV array shuts down when it senses a loss of grid power. Backup generators start up to serve the load at each critical building. At headquarters and the airplane hangar, backup generators don't start, perhaps due to a lack of maintenance. To prepare for islanding, the main electric service disconnect opens. This is done to prevent backfeeding electricity to the utility grid for safety reasons. At the main substation, all feeder breakers open. The peaker plant starts, energizing the main substation. Two critical feeder breakers close. This provides power to headquarters, the fire department, and the PV array. The PV array begins operating because it now senses grid power. Note that the load on the peaker plant drops after the PV has come online. The additional power provided by the PV reduces fuel consumed by the fossil fuel generating resources. The remaining feeder breakers close, providing power to the rest of the base. The load on the peaker plant increases. As the backup generators shut down, the load on the peaker plant increases even more. Operating an islanded microgrid. Note the introduction of the orange meter in the lower left corner labeled Building Automation Systems. If the power outage continues for a longer period of time, the base may consider reducing or disconnecting non-critical loads to reduce fuel consumption. Building automation systems can assist with this. As power consumption is reduced at non-critical buildings, power output of the peaker plant is reduced as well. Because these are non-critical buildings, the building automation system is putting them in an unoccupied state. When all the backup generators are shut down, the peaker plant load increases to 100%. The backup generator at the airplane hangar is repaired. When it starts, the peaker plant load decreases. The backup generators in this microgrid have been modified with controls and switchgear that allow them to operate in parallel with the peaker plant. The peaker plant is a prime power generator, meaning that it is designed to follow the load and operate continuously for long periods of time, for example days or weeks without shutting down. Even though backup generators are designed to operate for only a few hours at a time, they can be an important part of the microgrid. The backup generators now cycle for short periods of time to optimize fuel use or meet temporary higher load conditions. To conserve even more fuel, an entire feeder can be disconnected if it's not needed.